So to do an example, let's say that h of s is equal to 1 over s plus k, so it's standard first order form. So this would come from a transfer or a differential equation that would be like y dot plus ky equals some f of t, or let's call it u of t. And so then I can look at h of j omega as 1 over j omega plus k. I need to rationalize that, so I multiply top and bottom by the conjugate, and I get k minus j omega all over. I have an omega squared times j times minus j gives me minus minus 1, so that's just omega squared plus k squared. And then I can look at the magnitude of h of j omega, and that's equal to square root of k over omega squared plus k squared, all that squared, plus minus omega over omega squared plus k squared squared, which is going to be k squared plus omega squared square root all over omega squared plus k squared, and that's just 1 over the square root of omega squared plus k squared. There's my magnitude, and the phase now is going to just be the inverse tangent of, notice here's the imaginary part, here's the real part, but notice they both have the same denominator, so I have minus omega over omega squared plus k squared over k over omega squared plus k squared. Those drop out. I end up with tangent inverse of minus omega over k, which is equal to minus tangent inverse of omega over k by trig identities. So there's my phase. And I could go ahead and plot the two now plot for all omega from, say, 0 out to infinity. And I would end up with a plot that has, there's the frequency, so that's going to be, and I'm going to use log of the frequency, and over here I'm going to use log of the magnitude, and there's a reason we choose logs here, but, and I'll just say there's 1, and there's, say, 10 to the 0 or 1, and then I can also plot the phase angle, and so there's phase. And what we would find in this case, notice as the frequency gets larger and larger, when I start at 0, I just get 1 over k, and then as the frequency gets larger and larger, this thing goes off to 0. So when I take logs, I'd get something like, this is really 10 to the, well, let's see, it would look something like this. And then down here on the angle side, notice we've got tangent of, inverse tangent of something that's going from 0 all the way out to infinity, and you'd find you'd get something that starts at 0, and here's 90 degrees down there, and it would come along, and then it would try to drop off and go around. And I could plot this for different values of k if I wanted to, but the shape would basically stay the same. So for your in-class group exercise, number 3, I want you to basically go through the same process, but for a spring mass, a mass spring damper system.